Hello, everyone, and welcome to section 4.5, Solving Polynomial Equations in Algebra 2. So if you were in class, I actually would not do these first four graphs for you. I would put you into your groups and tell you to figure it out. So that's what I would do if I were you. I would really try and think about what you know and what you've learned this year that would help you to make this graph. So hopefully you're just coming back now after having at least attempted it. But of course, you know I am going to do it for you. So there's a bunch of things I know about this graph. I know that it's cubic, so I know that's going to be its general shape. It could have been going down, but the first term is positive, and that's how I knew that it was going up. An easy point to get is the y-intercept. The y-intercept is always just when x is 0, which in this case, when x is 0, y is 0, so I already know one of my points. And then I can factor. That was the big hint. So I'm going to take my y, and I'm going to take out the x, which gives me x squared plus 4x plus 4. And now don't forget to rewrite that x. I'm going to factor further. This is what we worked on last time. And this is what we call a repeated solution or a repeated factor. So I'm going to go ahead and square it. So what would cause this to be equal to 0? Two numbers. If x was equal to 0, then you would have 0 times 0 plus 2 squared, which would be 0 times 4, which would be 0. So x is equal to 0 is one of them. Or if x is equal to negative 2. And I know some of you are surprised that I'm sitting here doing this little extra step here. You don't have to do this. I just really don't think people always understand why they say x is 0 and negative 2. But it's that if x was negative 2, this would be 0. And then 0 squared times negative 2 would be 0. Those are the two numbers that make the equation 0. But that only works when something is factored. If you have x plus 2 is equal to 0, then negative 2 does work. But if you had x squared plus x plus 2 is equal to 0, you have no idea what's going to make that 0. It could be 4 and then negative 2, negative 4 and then positive 2. There's lots of things that it could be. But when it's in factored form, there's no choices. It has to be 0 or negative 2. And that's why factoring is so important to us. All right, so I'm going to go ahead and plot those. I've already plotted 0 because that was also the y-intercept, and negative 2. Now, normally, excuse me, normally a cubic graph has 3 zeros, but this only has 2. But that's not true. It's that negative 2 is twice. It's a bounce. Remember that when a 0 is repeated, it's a bounce. So I'm going to make this graph by coming up, bouncing on that, and then I'm going to go through that 0. Is this exactly what it looks like? Maybe not. Maybe it's the red one. Okay. It's okay that you don't know. As long as you have the general shape and the bounce and the correct y-intercepts and the correct x-intercepts, you're good. All right, so if that's what you needed to kind of get you motivated and started, I hope that now you will try the next 3 graphs on your own. But of course, I will do them for you. So you may remember that I said I always take out a negative. I think that makes it easier to factor. Minus 4x squared plus 2x minus 8. And this has 4 terms, which is one of my favorite kinds because it's a little bit easier, because once I know that it's x squared and x, I know that the 2 has to go across from the x because I need the 2x. And I know that there needs to be a negative 4 across from the x squared. And sure enough, the last times the last makes the last. So this is what my y is equal to. When I set that equal to 0, I have this funny problem where this one's easy, x is equal to 4, but what squared plus 2 would make that 0? Well, if you're not sure, if you can't do it in your head, then actually set it equal to 0. And of course, that's imaginary. You can't take the square root of a negative number. You would get plus or minus the square root of 2, and then I. So what an imaginary 0 means is it means that the graph has another bump. So we know that this is cubic and negative, so we know it generally looks like that. But we know that that bump must happen either above or below the axis, and that's why it didn't cross. It didn't come all the way down and make a total of the 3 zeros. Instead, there's just the 1 0. So it could have been a bump up there, or maybe it came down first and then did that. So the bottom line is you're not totally sure, but remember, we can plot the y-intercept. So in this case, when x is 0, y is 8. So always plot your y-intercept. And I know that it crosses at 4. 1, 2, 3, 4. So how you draw exactly from there, I'm not really sure. But oops, I kind of missed that, didn't I? There we go. But as long as you've plotted the y-intercept, you've shown its cubic shape, you've plotted the 1x-intercept that you know, you're good to go. Okay? Number 2. Again, if you haven't done it yet, try it on your own. So don't forget factoring out first. I can take out a 2 and an x. That leaves me with x squared minus 6x plus 9, which then becomes x minus 3, the quantity squared. So either x is equal to 0 or x is equal to 3. This one is going to be a bounce because they're of the square. So at 3, there's a bounce and 0. The y-intercept is already seen, but just so you can see that if you had plugged in 0, you would have gotten 0. So since I want to bounce at 3, and my general shape is a positive cubic function, I'm going to go up through and then make the bounce on the downswing. If you had gone up, you can't bounce at the 0. You have to bounce at the 3. So that's really the only way to get that. If you had plotted one more point, if you want it to be a little bit more accurate, if you're doing something important, then you could pick an easy number like 1. If you plug in a 1, you get 2 minus 12 plus 18. 20 minus 12 is 8. So 1, 8 is one of the points. Well, knowing that 1, 8 is one of the points helps you kind of get that steepness going. The danger of that is, and the only reason I don't always require it, is because sometimes kids make that the peak. You don't know that that's the peak. You won't learn how to do the peak until the maximum until calculus. So you're welcome to plot an extra point to kind of gauge how steep you should be drawing it, but don't do this. Don't go up and then make that the top of the graph, because it isn't necessarily true. Okay. Last one. Again, factoring out first, I'm going to take out a negative 2, which leaves me with x to the 4th minus 8x squared plus 16. I can factor that to x squared minus 4 times x squared minus 4. Since there's a square, I look to see if I can factor again, and I can. X plus 2, x minus 2, and x plus 2, x minus 2. Which means I can rewrite this as x plus 2 squared. There's 2 of them, and there's 2 x minus 2's. Now I want you to be careful here. Sometimes kids tell me that there are 3 zeros. They say 0, negative 2, and 2. And they get that 0 from this. Having a number on the outside doesn't make one of the answers 0. So be really careful that you don't make that mistake. Think about it this way. If you had 0 is equal to 2 times x plus 1, if x is equal to -1, you'd have 2 times 0, because -1 plus 1 would be 0. But if x was equal to 0, which is the answer that people give all the time, you would have 2 times 0 plus 1, which is 2 times 1, which is 2. It just doesn't work. Having a number on the outside does not affect the factors becoming 0. So, little mistake that people make often, which is why I'm bringing it up. So these are both bounces. So at -2, there's a bounce, and at +2, there's a bounce. And my y-intercept is 0, -32, which I can't graph. But I do know the general shape is an M because it's quartic and it's negative. Those two things are what tell me what the shape is going to be. So now that I know the shape and I know I want it to go down, what I'm going to say is make sure you don't actually draw the y-intercept. It would be super easy for somebody to draw it like this. But the y-intercept is not there. You cannot draw that. If you were to graph this on your graphing calculator, sorry, I wanted the back arrow, but not back a page. There you go. If you were doing this on your graphing calculator, this is what it would look like. It would not be able to show you that y-intercept. It would have the graph just look like it kept going down. You've probably seen that, where you can't see a whole parabola or something. So that's what it looks like. All right, so we've done 4 graphing. You'll have some for homework. The key is factor and y-intercept. Writing equations of functions given zeros. So this is a nice part of the lesson, very easy. We're just going to go backwards. So if I tell you that the zeros are -2, 1, and 3, then the factors must be x plus 2, x minus 1, and x minus 3. That's it. Now I have to warn you, your book is going to multiply that out. That is a lot of work, a lot of kind of busy work, because you'd have to multiply 2 of them together first. X squared, inners and outers make x minus 2. And then you'd still have to multiply by x minus 3, which again is a lot of work. So you can leave your answer like that. It won't help you check it in the back of the book. But you have 2 options. One is you could check it online where they show all the steps, and this is definitely going to be the first step they show you, or check it with a friend, okay? On this one, if 4 is a 0, then x minus 4 must be a factor. If -1 is a 0, then x plus 1 must be a factor. And if 5 is a 0, then x minus 5 must be a factor. These are your favorite, right? The irrational conjugates theorem. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that the square root of b is irrational. If a plus the square root of b is a 0, then a minus the square root of b is also a 0. So what that means is they're only going to list the square root of 3, but you know that minus the square root of 3 is also a 0. And think about why that happens. It must have come from something. If one of your factors was x squared plus 9, or that'll give you an I. We won't do an I yet. X squared minus 3, which is what this one would be, then if you set that equal to 0, you would have x squared is equal to 3. But when you took the square root, what would you have? Plus or minus. See, so they're always going to come in pairs. That's pretty much what they're saying, is that if this is a 0, then you know this is a 0. Think about the quadratic formula. -b plus or minus. There it is, plus or minus the square root. There's always going to be 2. The other one might be easy to find, but if there's a square, there's going to be a plus or a minus. So we can write this the exact same way we just did. X plus 2 must be a 0. X minus the square root of 3 must be a 0. But it's your job to think of this on your own. They're not going to give it to you. So x plus the square root of 3 is the last 0. Now, while I did say that you can leave your answer in factored form, you may not leave anything irrational. So for me, you may leave your answer in factored form, but you may not have any irrational numbers, which means I'm going to do at least the first step of this. So first, outer. Now watch this. This is great because these are conjugates. Which means that they're the same, but they have different signs. One's plus and one's minus. The inners and the outers are always going to cancel. That's the great thing about conjugates. So x squared, the inners and the outers cancel. And then the square root of 3 times the square root of 3 is the square root of 9, which is just 3. You don't have to finish that multiplication, although your book will. So you either need to multiply it out to check it or go online and see if this is one of the steps. This will be step 1, this will be step 2, and then step 3 would be the answer. So you can check the online solutions that way. All right, so if 2 plus the square root of 5 is one of the solutions, then 2 minus the square root of 5 is another one. Think back to quadratic formula there. This is a lot harder. So here's my answer. Y is equal to x minus 3. There's the easy one. Now, if I were you, I would do this, x minus, because that way you won't forget this minus. This is unfortunately where a lot of people write plus and minus, but it's not there. It's x minus this, 2 plus the square root of 5, and then x minus this, 2 minus the square root of 5. Think about that. Every time you've ever done a 0, you've always done x minus the number. So it's the same thing here, x minus the number. That change in that plus or minus doesn't happen until right there. So you can't leave that square root in your answer. It is a little bit ugly. So step 1 is going to be to distribute your negative, x minus 2 minus the square root of 5 times x minus 2 plus the square root of 5. And then your next step is going to be to multiply it out. So my first step is going to be to distribute the x. So I'm going to distribute the x to all 3 of these things. And I get x squared minus 2x plus the square root of 5x. Now I'm going to distribute the 2 to all 3 of these things. That gives me negative 2x, which I'm going to go ahead and put underneath this one to kind of start collecting my like terms. And then the negative 2 times the negative 2 is plus 4. I don't have any regular numbers, so I'm going to put that off to the side. And then I have negative 2 times the square root of 5, which is negative 2 square roots of 5. Then I'm going to distribute the square root of 5 3 times also. So negative square root of 5 times x, I'm actually going to put that with this one. Look at that, they're going to cancel. And then negative square root of 5 times negative 2 is plus 2 square roots of 5. This is working out nicely. And then negative square root of 5 times the positive square root of 5 is negative square roots of 25, which is just negative 5. So I'm going to put that here. And all together then, don't forget to bring down your x minus 3. X minus 3 times x squared minus 4x. These cancel, minus 1. So again, you can stop here. You're not required to continue the multiplication. It's a little long and tedious, but that is how your book will give the answer. But I want you to understand what's happening here. The question is, when is this equal to 0? Well, the easy one is 3. See, that's one of the zeros. But if I said to you, when is x squared minus 4x minus 1 equal to 0? Hopefully your first step would be to try and factor it. But when you couldn't, how would you do it? You would either complete the square or you would use quadratic formula. So just because it's easier, I'm going to complete the square. X squared minus 4x. I need a little plus 4 in here. So I am going to put that 1 on the other side. And then I'm also going to add 4 to this side. Sorry about that. So I'm going to add 4 to this side. This side becomes x minus 2 squared is equal to 5. X minus 2 is equal to, I square root both sides, and I get plus or minus the square root of 5. And x is equal to 2 plus or minus the square root of 5. Does it make sense now? The zeros are 2 plus the square root of 5 and 2 minus the square root of 5. That's what I got. So what we're doing now is we're going backwards. I'm showing you how to get the original polynomial that created the answer 2 plus or minus the square root of 5. Now, for those of you that didn't like completing the square, of course, there's also just using the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac. What is that? Negative 1 all over 2a. So x is equal to 2 plus or minus. So this becomes 20, the square root of 20, which is 2 square roots of 5, because it's the square root of 4 times the square root of 5. So 2 square roots of 5. It's over 2, but I'm going to do them individually to make sure that I do it correctly. Oop, this is a 4. I knew it was going to be a 2. I just thought about it in my head too fast. So anyway, it's 2 plus or minus the square root of 5. So like I said, this is learning how to take the answer to a quadratic formula problem and go back to the original polynomial. And how do we do that? By doing x minus one of the answers and x minus the other one of the answers. You don't have to do any of this that I just showed you. I'm trying to make sure that you're making the connection between the two concepts. Okay, last one. I would like to think you'd practice it on your own, so I am going to quick write the answer. F of x is equal to x minus 4 times x squared minus 2x minus 2. But of course, we are going to do it out. Y is equal to x minus 4. And then remember, my advice is doing x minus and x minus. And then this is 1 minus the square root of 3 and 1 plus the square root of 3. Those are the two answers. All right, I'm going to go through this one a little bit quicker now that we've talked about it. Not that quick, though. X minus 1 minus the square root of 3. And that gives me, distributing the x is x minus square root of 3x, and then minus another x, and then a plus 1, and a plus square root of 3, and then distributing the square root of 3, I get square root of 3x minus square root of 3, and square root of 3 times the square root of 3 is just 3, so minus 3. For a final answer of x minus 4 times x squared minus 2x, these cancel, minus 2. There you go. A little bit tricky, so good job. So all these concepts are related to each other. What we started with in the beginning, we did so we could graph this. Now all we want to do is solve. So solve always means find the value of x to make the equation true. So our goal is just going to be to set it equal to 0 and factor. Don't forget about factoring out first. So I can take out a 5 and an x, which gives me x squared minus 8x plus 16. 5x times x minus 4 times x minus 4. And so my answers are 0, the 5 doesn't matter, or 4, which you are not required to list twice. I'm going to take just a minute and write down the rest of the answers because honestly, I'm not teaching anything new here, and if I had been in class, you would have been doing these on your own. But of course, I am going to do them for you. Number 5 is x is equal to plus or minus 1. And number 6, x is equal to 0, negative 3, and 2. So I can't stress enough that you really should be doing these on your own. But in case you need to go back and look at one, I will do them. So set it equal to 0, which we didn't have to do on number 1. That was already done. So 4x to the 4th minus 40x squared plus 36 is equal to 0. I can take out the 4, which gives me x to the 4th minus 10x plus 9 is equal to 0. Oops, there's a square there. X squared minus 9 times x squared minus 1. Remember that when you have a number like 9, you should always try 3 and 3 first. But as you get better at factoring, you'll be able to see ahead and say, well, 3 and 3 will either make 6 or 0. And I need 10. So I'm going to choose 9 and 1. And then this becomes 4 times x plus 3 times x minus 3 times x plus 1 times x minus 1. And so my 4 answers are the negative 3 and the positive 3, which you're welcome to write as plus or minus 3, and the negative 1 or the positive 1, which you're welcome to write as plus or minus 1. Number 2, again, it's not equal to x squared, and not only that, but when I move it over, make sure you write it in descending order. This is very similar to the last one, in that it's another one of these x to the 4ths that you can factor into x squared, in this case minus 9, and x squared minus 9. They're the same factor, and that gives me x plus 3, x minus 3, x plus 3, x minus 3 is equal to 0. But you do not need to list the negative 3 twice. You can just say x is equal to plus or minus 3. Next one, set it equal to 0. And this is going to be your strategy throughout your next several years of math. Whenever you have an equation with a higher order, if it's just an x, then you just solve it. But as soon as it's got that x squared in it, you're going to want to set it equal to 0 and factor. Don't forget about factoring out first. I can take out a 2 and an x. That leaves me with x to the 4th minus 7x squared plus 12, which is 2x times x squared minus 4 times x squared minus 3. And you can factor this one further, x plus 2, x minus 2. Because there's a minus, I can make 1 plus and 1 minus, and then my inners and my outers will cancel. But I can't factor this one any further. But it doesn't mean you don't have to solve it. You do. You just have to solve it by hand. Remember, when then there's no x term, you can just solve it regularly by moving the 3 to the other side and taking the square root of both sides. And then my other 3 answers are x is equal to 0, x is equal to negative 2, and x is equal to 2. So my final answer is 0, plus or minus 2, and plus or minus the square root of 3. The order in which you list the answers doesn't matter to me. We have 2 more. If you still have not tried one on your own, you really should do that. Now I'm going to move this to the other side because I really like it when my first term is positive. I think that makes it easier to factor. If you moved everything to the left, you could factor out the negative. That seems like a little extra work. So I'm going to take out my 3 which leaves me with this. And then I can factor further, x squared minus 1 times x squared minus 1. So we've done so many of these, just to do one a little bit differently, you could stop here and just set this equal to 0. And you don't have to do both of them because they're the same. If you did that, though, my only hesitation is don't say 1. It's plus or minus 1. So don't forget that plus or minus. And also, don't forget that 0 is equal to 3 is not one of the choices. So there are 3 things being multiplied together to make 0. One of them is equal to 0. It's not the 3. Okay, number 6. So of course, I see an x cubed in my problem. The first thing that I'm going to do is set it equal to 0 and factor. The first kind of factoring you always do is factoring out. And then if you still have a square or a cubic, you can try and factor further. This one is x plus 3, x minus 2. And my 3 answers are 0, -3, and 2. All right, so now we have 5 word problems that we'd like to tackle. The first one says, the profit in millions of dollars for a t-shirt manufacturer can be modeled by the equation P is equal to -x cubed plus 4x squared plus x, where x is the number in millions of t-shirts produced. Currently, the company produces 4 million t-shirts and makes a profit of 4 million. What is the lesser number of t-shirts that the company could produce and still make the same profit? So they're saying, look, right now we do 4 million and we make it a profit of 4 million. Is there any other time could we have a different number of t-shirts and still make 4 million? So we're going to set this equation equal to 4 million. Now don't actually do 4 million. Remember, the profit is already in millions, so you can just write 4. So I am going to set this equal to 0. Of course, I'm going to move everything to the other side because I think I told you that I really like when my first term is positive for factoring. This is a cubic equation with 4 terms, but I like those because I know it's x squared and x. And then I look at my inners and I see I need a negative x, so this is -1. And I look at my outers and see that I need a -4x squared, so this is -4. And the last times the last makes the last, so I know I did it right. And then on top of that, I can factor further. X minus 1, x plus 1, and x minus 4. So there are 4 times when this cubic equation is equal to 4. When x is equal to 1, when x is equal to -1, and x is equal to 4. So right now, they've chosen this one. They're making 4 million t-shirts, and they're getting $4 million. But they could do, hold on, could they do negative t-shirts? No, these are t-shirts. They can't do negative. But they could do 1 million t-shirts. And this is what happens with companies, is that they have this cubic equation and they're saying, look, our goal is $4 million. And there's going to be more than one way to reach that goal. The negative one, of course, doesn't matter. But if their profits follow a cubic equation, then the same exact profit could be yielded by 2 different x values. And of course, you want to choose the less one. You want to make less t-shirts and still make a $4 million profit. So what is the lesser number? 1 million. Now to do this next one, you do need to know the volume of a cube. So let's go ahead and fill that in. X cubed. This says that the volume of a given cube is 8 centimeters, and each side has a length of x minus 3. Write a polynomial equation you can use to find the value of x. Solve the equation for x and state the dimensions of the cube. So x minus 3 times x minus 3 times x minus 3. So normally it's just x cubed, but in this case, if the length of the side, maybe I should write this as side cubed. So since the length of the side is x minus 3, I need x minus 3 times x minus 3 times x minus 3 is equal to 8. So this, I'm going to show you something that's very cool. I'm going to show you how to do it on the calculator. This particular one does have another way of doing it. So in case you saw it, you could do x minus 3 cubed, and then you could take the cube root of both sides. So on the outside chance that you thought of that, x minus 3 is equal to 2, x is equal to 5. That's great. But if you hadn't been able to do that, if it hadn't been a perfect cube, if it had been x minus 3 times x plus 1 times x plus 2 or something like that, you would have gotten stuck. So what I'm going to do is I'm going to show you on your calculator how to solve any cubic equation, any equation. We've done this before, but we're going to do it again because you really need to understand this method. So take out your calculator. I know some of you are just going to watch me, which is fine, but you better make sure you can do this on your own. You will need this for number 49 and 51 on your homework. So I'm going to go to y is equal to, which is up here in the corner. And the great thing about doing this on your calculator is your calculator does not need you to multiply out the polynomial. It is perfectly content with your leaving it as x minus 3 times x minus 3 times x minus 3. And then the other value is going to be 8. So I'm going to graph both of those. Now, if you're not sure what your last graph was, you might want to hit zoom 6 first. It just kind of puts it back at a normal window. And there you go. There's the cubic function, and there's where it crosses 8. So you can instantly get the answer by plugging in the two sides of your equation. I do second calculate to find that point of intersection, which is number 5. It does ask you what the first curve is. Mine's colored, so it's blue, but it will always say it right there, y1. And you just have to enter. It's saying, is that the one that you want to check? And is this the second one? You just hit enter, like, yep. It does ask you to make a guess, which is really important if you have more than one thing happening, but we don't. So we can just guess whatever. And there you go. When x is equal to 5, then the volume of the cube will be 8. So this is a great way to do a problem. On this next one, it says that the volume of a rectangular birdcage can be modeled by the equation v, which I've already typed in for us, where x is the length in inches. Graph the model on your graphing calculator. So this can be tricky because I don't really know what window I need. So I usually just start with zoom 6 and see what happens. Now remember that this represents volume for different lengths x. So I actually don't need the negative portion at all. I can start at 0. I'm not going to have a negative length. And I'm also not interested in a negative volume, so I can hit 0. So if you want, you can switch your graph so you're only seeing that y-axis, or that first quadrant. So you can see that when x is just bigger than 1, it has a little tiny volume, but then it becomes negative again. But then somewhere around 3, the volume becomes positive again, and the formula that they gave you works well. Let's see if that's exactly 3. We can find that by doing second calculate. Now, I'm going to say intersect, but I don't have a second curve. So I could go back and make a second curve. I want to know where it intersects 0. Or another feature that you could use is just this one, find the 0. Tell me where that 0 is. So I think it's at 3, but I can definitely tell it's between 2 and 4. So my left bound is 2. And then look, it's going to ask for your right bound. I'm going to say 4. Do I make a guess? Sure, it doesn't matter what a guess is. And there, sure enough, it is right at 3, 0. So this bird cage, you're really only going to want the volume if x is greater than 3. You can make a really tiny bird cage if x is between, and you could find those two zeros. But it would be a pretty tiny bird cage. All right, going on to number 4. Some ice sculptures are made by filling a mold and then freezing it. You are making an ice mold for the school dance. It is to be shaped like a pyramid with a height 1 foot greater than the length of each side of its square base. So let's try and picture this here. Ooh, it's not going to be good. All right, pretty good. So the volume of the ice sculpture is 4 cubic feet. What are the dimensions of the mold? So to do this, you need to know that the volume of a pyramid is 1/3 the area of the base times the height. But since our base is going to be a square base pyramid, some people might write it as x squared h. Either formula is good to know. So for us, though, it says the pyramid with a height 1 foot greater than the length of each side of its square base. So if these are x's, then this height in the middle is going to be x plus 1. So my volume is 1/3 x squared times x plus 1. And my volume is equal to 4. So you could, if you would like to try another one on your calculator, you could type 4 on one side and this on the other side, and you could get your answers that way. I am going to do another one by hand because I wanted to show you about clearing the fractions, which I think is really important. So times 3 on both sides. That gives me 12 is equal to, and I'm going to multiply that out, x cubed plus, wow, my pen is not happy today, x cubed plus x squared. So I set that equal to 0, and I get x cubed plus x squared minus 12 is equal to 0. Ooh, that is not factorable. So when it's not factorable, this is when you have to use your calculator. So it doesn't matter which equation you use, this one or this one. If you graph this one, whatever it looks like, you're going to be wanting to know where this is equal to 0. If you graph this one, which is also some kind of cubic, it's going to be different though. You're going to want to know where it's equal to 4. But the places where that happens will remain the same. So it doesn't matter which one you do. So some of you are going to start problems by hand and then get stuck. And when you get stuck, you can just figure out where this equation is equal to 0 on your calculator. We just practiced that a minute ago. Or you might start right away and want to know how to do it on your calculator. It is up to you. I will let you do it however you want, but the answer is 2 by 2 by 3. Don't forget your unit, which is feet. Number 5 says you are designing a marble basin that will hold a fountain for a city park. The sides and the bottom of the basin should be 1 foot thick. The outer length should be twice its outer width and outer height. What should the outer dimensions of the basin be if it is to hold 36 cubic feet of water? So if we were in school, I would be trying to let you figure this one out, try and understand the wording of it, because it is a little bit tricky. But obviously we're not out of school, so I'm going to draw it for you. So we have this marble basin, and it says specifically that its length is twice whatever its width is, and its height. I'm actually going to make it just a little bit shorter because its height is also x. But then it has an interior. That's where the water is going to go. And even though you wouldn't actually be able to see this, so I'll kind of make it dotted. It goes down into the basin like that. And that's where the fountain's going to come from. There's water in there. And this distance on either side is 1 foot. And the distance, so it also doesn't go all the way down to the bottom. There's 1 foot at the bottom. So we want to find the dimensions. Basically, it's a prism, rectangular prism, whose volume is length times width times height. And they gave us this blue dimensions, which is 36. So what are the dimensions of the little blue space? Well, if the entire thing is x, but they came in a foot in either direction, then it's going to be x minus 2. That will give you that inner dimension. And then the other one, again, they came in a foot on either side. So you start with that 2x, but they came in a foot on either side. That's also minus 2. And then the height is x, and then again, minus 2. No, sorry, minus 1, because you don't come in from the top and the bottom. So just minus 1. So again, you have two choices. You could do it by hand, or you could type this side into your calculator as y1 and this side into your calculator as y2 and see what answers make sense. Keep in mind that this is going to be a cubic equation if you were to multiply it out. So there's several answers, but that doesn't necessarily mean that all of the answers make sense. Okay? But the length, the final answer that you can do by the method of your choice is going to be 8 feet by 4 feet on the base, and then by 4 feet high. So we do have some challenging things left to do. The first is factoring. But again, I really like when there's 4 because I consider that a puzzle, assuming nothing comes out. Can we factor out first? Factor out first. I always try that. I see a 7, but not in everything. I see an A, but not in everything. A C, but not in everything. A B and a D are not in everything. So no, we can't. So I'm going to skip straight to this. And the key is you just have to do reverse FOIL. So I need to make a 7a c squared. I don't know how to break it down, but I do see another c squared without an a. So I'm going to take my c squared, and I see that the a went with the 7, and I'm going to break it down that way. And now the c squared went with the b for outer, so I'm going to put the b there. But if the b goes there, then the d squared must go there. And then I check it. First, outer, inner, that's going to have a negative, which means the last will have a negative if this is positive, which works out perfect. Now, if I put this on a quiz or a test, you would have gotten half the credit because it's not done. Whenever you have a square, you have to try and keep going. So c plus d times c minus d times 7a plus b. And for the record, whenever I see somebody gets an answer like what's in the box without the step above, I am very, very confident that you copied that answer, because even after all these years of doing math, I can't go straight from this to this. Okay, so don't attempt it. Make sure that you show your steps. The next one has a weird exponent, but again, I'm not going to let that intimidate me. Well, I'm going to do the easy part first, 1 and 1. But the inners and the outers kind of give it away. It's going to be x to the n. Because if it's x to the n, then when you multiply this, you get 1x to the n. When you multiply this, you get 1x to the n, which would give you 2x to the n if they were both negative. So the question is, does that work? Is x to the n times x to the n for the first, right? First, outer, inner, last. For first, does that give you x to the 2n? It does, because you add exponents. If you had x to the 3rd times x squared, you would have said x to the 5th in a heartbeat. You understand that concept. So x to the n times x to the n is x to the 2n. So a little bit of a puzzle here. Ooh, do I want to box that? Anybody see what I could do before I box it? I was about to box it. They are the same. So it would be better to write it as x minus 1, x to the n minus 1, the quantity squared. Okay. All right, and finally, 2 thinking questions. You divide f of x by x minus a and find that the remainder does not equal 0. So your friend concludes that f of x cannot be factored. Is your friend correct? Yes, because that's what it means to factor. When you, well, I shouldn't say that. It means that x minus a x minus a is not a factor. Okay, so in that sense, they're correct. Because if x minus a was a factor, then the remainder would be equal to 0. That's what it means to be a factor. 6 is a factor of 24, so there's no remainder. 6 is not a factor of 25, so there is a remainder. But it could just be that they're multiplying by the wrong number. So no, there could be a different factor. There could be a different factor. So I just thought of that. And that's why it's called a thinking question. So don't answer them too quickly. Last one. Is it possible for a cubic function to have more than 3 real zeros? So remember that a 0 is the same as an x-intercept. The graph of a cubic equation starts at the bottom and makes at most 2 turns. So it comes up 1 turn, 2 turns. So the most that it can have is 3 real zeros. It can't have any more than that. All right, you did it. This was a super long lesson. Thanks for hanging in there, and I hope you have a great day.